Hello everybody, today we're going to be going over the Project 4 for the Embedded Software Engineering course. This one is about flying the quadcopter with the provided flight controller. So looking at our table of contents, we're going to look at the problem overview, some of the requirements, design, implementation. We'll briefly cover over manual build instructions, test debug cycle, and then there's a few important notes that occurred, and then next we'll look at the results and the implementation. So problem overview, it's pretty simple. We got a QWinout DIY 450mm drone kit for the frame, and we have a KK flight controller for our main board that'll be controlling the ESC brushless motors. So the requirements for this is that we are going to assemble the QWinout DIY drone, calibrate it, and then demonstrate hovering the drone, demonstrate pitch, yaw, and roll. The design, this section is really just going over the required resources, and we'll add a drone image in here as well for future use. Um, so manual build instructions, I followed the QWinout's 450mm DIY drone frame build guide. And then there was a few things that I did after that was done just to tidy things up. The first was I actually attached the flight controller just with zip ties versus regular screws. There wasn't enough screws in the actual kit to use those as well, so I just zip tied it. And then I attached the ESCs to the kkmicrocontroller in the order of front right, back left. This was documented in the manual, but that's the order that just made more sense to me. And then I used double-sided tape to secure the antenna underneath the flight controller and route the antennas to the bottom of the drone. Some of the things that the manual didn't go over was that the legs that came with the kit were not actually included in the instructions. These need to be mounted with the initial arm mounts, and then you can route the cables from the servos or brushless motors to the ESC through the armholes as well and to the ESC where they may be zip tied. This can be cleaned up for the final product a lot more. You could also route the whole cable into the main drone body from the arms for a much cleaner look. So the general test debug cycle that I used, the first flight that I performed didn't go well. We flipped the drone multiple times. But from there, some of the problems that I ran into were propellers or props spinning in the wrong direction. So if you just switch the power and the ground on those servos, or the from the ESC to the actual servo, that'll actually switch the spin from clockwise versus counterclockwise. Adjusted the propellers so that they actually push air down for whichever direction they're spinning. There was 2 propellers in each bag. I didn't pay enough attention on the first build to see that, hey, the rotation matters, and then the propeller are actually different for which rotation they're meant for. And then I readjusted the battery and used a zip tie to actually hold it in place. This does mean that either you're cutting a zip tie or you're charging it on board the drone, but I thought it was a lot easier and I had longer zip ties versus the provided Velcro in the actual kit. Important note, when you're doing your initial startup, the guide says to actually have the throttle just out of 0 or the bottom, just to allow the gyro to calibrate a little bit more. And then after a few failed attempts, I was actually able to demonstrate the hover, demonstrate pitch, yaw, roll, etc. And we will be linking to that video shortly. So this video shows some initial drone footage that we were able to take. This was before the calibration was actually performed. We saw some squirreliness with just the control inputs and things of that nature. So we ended up doing a half turn, or actually closer to a 25, so quarter turn of the pitch, roll, and yaw. And that helped a lot with the squirreliness in future flights. The drone does fly off footage a little bit. It's kind of hard to take footage of a drone from a camera, so uh, in future videos that will be better. But this does demonstrate some initial drone flight, and it does show some pitch, roll, yaw, and then some initial landing. So that concludes our video. Thank you guys very much for watching, and I hope to see you next time.